You will remember from yesterday that we were looking at displacement time graphs, okay? And we maybe didn't quite get as far, maybe we didn't quite do as well as we thought we would. So what I suggested was, let's go ahead, let's do these 11 questions kind of for homework, and then let's re-enter our answers, and hopefully we'll do better this time, right?
I still got it.
Correct.
Okay, so you should have answers now. I haven't started it yet. I will right away. But I just want to point out that the intervals are labeled. See how they're highlighted there? Maybe I didn't do a very good job with this yesterday, but interval B is from there to there.
Oh, I know what it is.
And interval C is from there all the way down to there. And interval D is all the way from there to there, the flat part. And E is from there to there. And there's F, right? Okay, and do you remember how to find the displacements? You're looking at the x-axis, sorry, the y-axis here, right? I'm telling you how to do it now if you don't know. I'm giving you another hint. The y-axis is here, that's where you get the displacements. And then when you have to get to questions 6, 7, 8, how do you find velocity? The displacements that you got, and you have to divide by the time. Where do you get the time from? Down here. Each one of those marks is 1 second. You just count, and you divide by the time interval. Okay? There are 11 questions, right? Okay, so let's begin, and let's see if we can do a little better this time. Hopefully.
Did you fix the answers this time?
I did. Hopefully I saved them. Should I check first?
Yeah, maybe. Yeah.
Yay! Got number 1 right. What's the displacement? 0. Remember, flat line equals 0 displacement. Flat line is 0 displacement. Interval C should be negative 16. You go from there to there. Minus 10, subtract 6, or minus 16, right? Negative 10, right here. Subtract 6. Final minus initial. Interval D, it's flat. Yay, everyone said 0. Interval 4, it's up, so the displacement has to be some positive value. The correct answer is plus 6. How did we get that?
How did we?
The final position is minus 4. The initial position is minus 10. So I have to subtract negative 10. Minus 4 subtract negative 10 is plus 6. Interval 5, again, must be positive. Positive 4. How did I get that? Final position is 0. Initial position is minus 4. 0 minus minus 4? Plus 4. Any questions about displacements? How do you find average velocity? You take the displacement and divide by the time. Where do you get the time from? Down here. The average velocity for each interval. So for interval A, the displacement was 6, from 0 to 6. The time, count it, 1, 2 seconds. 6 divided by 2 is 3. Interval B, the displacement was 0. Do you even have to count the time? No. How come? Because it's going to be 0 divided by whatever the time is. What is the time? 1, 2, 3, 4. It's a big fat 0, isn't it? For 6. Number 7, for interval C, the displacement was minus 16. What's the time? 1, 2, 3, 4. Minus 4, right? Minus 4. Interval D, it's flat. I don't need to calculate. Flat means 0 meters per second. 0 velocity. 9 was positive 6. The d was plus 6. The time is only 1 second, giving me a velocity of 6 over 1, or 6 meters per second. Number 10, F. F is a displacement of 1. The time is 1, 2, 3, 4 seconds. You should get a velocity of 0.25. Is that the right answer? How come it says the correct answer is 1? There's something wrong here? Somebody help me out here. Should be 1 over 4, isn't it? 4 over 4? Oh, yeah, I see what I did wrong. Okay, so that distance there is 4, right? 4 over 4. I was right the first time. Excellent. Given this position time graph, determine if this represents a real-life situation. I haven't taught you anything about this. You just have to think. How come everyone said no? It's the correct answer. Is this showing back in time?
Yeah.
Sort of, right? How many people know what the vertical line test is all about? Nobody? One person. Grade, it should be somewhere in pre-calc. The vertical line test for a function.
You put a line through it and it crosses like 2 lines.
Exactly, right?
That's a very good.
Draw a vertical line like this, right? And you go across the function, and if it touches in 2 places, then it's not a function. Displacement is a function of time. In other words, you cannot be in the same place at 2 different times. Okay? You cannot be, actually, sorry, I should rephrase that. You cannot be at 2 seconds, right here. Sorry, 2 hours. You can't be at position 0, and you can't be at position 50 at the same time. Okay? In essence, you are going back in time here. But in more appropriate terms, you can't be at the same 2 different places at the same time. I think I said that backwards the last time. Does that make sense? Alrighty. I'm going to check to see who did what. How you guys did. You now have, can I borrow yours, Tyler? You should have, there's 1, 2, there are 2 graphs for you to practice with. 2 graphs for you to practice with. Okay, I would like you to practice with those. Do you have answers anywhere? Oh, you don't? Okay, I'm going to have to find your answers. Try those 2 graphs. I'll get answers for you somewhere. That's very weird. Okay, well, let's see here. I'm going A to E. Delta X from 0 to 4 is how many seconds, or how many, I guess it's meters, right? 8. I have 8. B would be 0. C would be minus 12. D would be 4. And E would be 0. Okay. So I think, did everyone do more or less okay there? All good? Thumbs up? Okay. If you have an earbud in, you should get it out so you can hear me. 8, or F, I'm assuming, is from 0 to 4 seconds, right? So that's going to be 8 over 4, which is 2 meters per second. G is, I'm assuming, from 4 to 6 again. 0 over 2, which should be 0. H is going to be minus 12 over 4. Is it 4?
Yeah.
Okay. Minus 3. I've got a slightly older version that I don't have. I have some stuff missing. What does negative 3 mean?
Left.
Just means that it's moving to the left. That's all. That's all it means. Negative means left. So I then is going to be 4 over
20.
20 over 4?
What?
Isn't it 4? Isn't D 4, right?
Oh, I
Yeah. So it's 4 over 4. Do we all agree it's 1?
Yeah.
Okay, and J is 0, so that's automatically displacement 0. It's going to be 0 over 14, 0. Now, how can that be? how can we have a graph?
Here we go again.
Here we go, let's just do this here. I want to, I'm right, Nate, don't worry, I'm right, but I want to make sure that everyone else gets this. How can we have, how can we have from 0 to 14, how can we have an average velocity of 0 for the whole thing? How can the average velocity be 0 when it clearly went somewhere? Exactly. It starts and ends at the same spot. The overall displacement is 0. It ends up there, right at 0. Does it matter, Gage? Does it matter that it is 0? Like, what if the graph was Would that matter?
No.
It still starts and ends at the same place. Okay? Are you ready for answers for part B yet?
No.
Okay, try part B. I'll be back in a couple minutes. Here's the answers. The displacements are as follows. You should have, I'll put displacements in black. So you should have 16, 0, minus 6, because it's down, 0, minus 12, 0, 4, all meters, and the overall displacement, plus 2. Well done.
Oh, my God.
Because it ends at 0, it starts at minus 2, right? So 0 minus 2. Okay, the velocities, you just take all those numbers and do what? Divide by the time. I'll do them in red. So I got 8, 0, minus 2, 0, minus 4, 0, 4 over 1 is 4, and then the overall? 0.14. Are we all good? Huh.
This is our test. We got 100.
That'd be sweet.
This is one small portion.
That's what I thought.
One small portion. Okay, let's have some fun. What do you see up here on the graph as we're playing with the card? Okay, what kind of graph is this? Is it displacement? Is it velocity? Well, it says position here on the side, right? So it's telling the computer the position of the cart away from the little motion sensor device here. Now, I don't know why you can't hear it. Usually you can hear it.
Yeah, it was.
Oh, you could hear it? It was ticking, right? Okay, so what it does is it works on sonar, just like dolphins. It sends out a sound wave, it bounces off the cart, and then it comes back, and then it uses that, it figures out how far away it is, and it does that every, like, 1/100th of a second. Kind of thing. Okay? So, on your sheet,
What if we didn't have a card?
if you just leave your hand like that, go ahead, put your hand there. Right?
Why is he going up and down still?
Because he's moving his hand.
Oh,
So it's picking up, and then all of a sudden it jumped because, yeah,
I picked up the
it
card.
picked up the cart because he moved his hand. Okay, so here's what we're going to do. You've got 3 little scenarios there. You got 3 little scenarios. For each description, determine what the DT graph will look like. You should note away from the motion detector is always positive. I've got it set up so that to your right, towards Gage over there, is positive, right? Towards the door over here, that is?
that would be negative for him. We should have a long second.
Okay. So, you've got 3 descriptions there where it says, yes, I want you to draw a little graph and tell me what you think the graph looks like. Put your phones down, draw. And then I'm going to actually do them, and then you're going to find out the actual answer. Okay, let's put it at 0, and we're going to go to the right and then immediately to the left. So, can you handle that? Right? And then right back left, real quick.
Maybe like a triangle.
Can you reach that far?
All that way, like a dog.
Well, if it goes to like here, or wherever, if you want to stand up and then do it.
Go on the other side of the damn.
Is that what you had? Something like that?
Dude, I had a triangle.
Now, you might have yours triangular, that's right. Remember me talking at one point, remember me asking at one point what you thought, how to make it a perfect sort of peak? Like, you can tell here the slope did what at the very end?
So if we-
Slowed down a little bit. How come? Because his arm runs out of
Arm.
arm. He runs out of arm, exactly. Let me see if I can do it. Standing up, it's a little bit easier. Woo! There, we got a nice sharp one, right?
Oh, I got the good one.
Oh, that's a good one.
I guess the leg keeps
Yeah.
You really expensive.
Oh, it goes right here, really tight.
Probably most of my allowance.
Let's slide that leg down. So that doesn't happen again. There we go. Okay, so all you gotta do is give it a good push. That's probably
Like Taylor's your textbook.
like not
Like a,
This is bad. I didn't
yeah, that's perfect. Okay, let's try this here. Now, why does it do that? See that nice sharp point?
Is it one higher?
can't go anymore.
Because we're not pushing with our arm, right? She pushes it, and then it's moving at a constant velocity, and immediately it changes direction. When you do it with your arm, you have to slow down before you can come back. Okay, that's a nice bounce off there. Hopefully you had a triangle like that, did you?
Well, mine's like this. Mine's like a big triangle.
Okay, whatever. Second one, car moves left, stops, then slowly right. So Kia's going to have to do this one. We're going to start over here. We're going to go left, stops, and then slowly to the right. You might have to stand up.
Just slowly left and slowly to the right.
Does it?
Yeah.
Let me get rid of these.
last word.
So it's left, stops, then slowly to the right. So a little slower.
So fast, left.
Fast at the start, slower the second time.
What? Slowly left.
Did you have that?
Let's go for both ones on
Yeah.
here. Let's do it on right.
Oh, it does
Oh,
say
wait,
slowly left.
Yeah, you told me that.
Slowly left, slowly right. Okay, well, let's look at this one. Before we do that one, how can you tell that this is
It says stop. Slowly
this
left.
is fast, it's steep,
It
right?
says slowly left.
Okay, we're going to do that one. We're going to do that one. Nate, we're going to do that one. Holy. Slow, yeah. And then stops. Oh, yeah, that looks good.
Oh, yeah.
Mine's the opposite.
How can you see stopped? Right, oh. That's not what I wanted to show. How can we see stopped? That flat bit right there is stopped.
He is too shaky.
Where is the,
You're too shaky.
your axis should be there. Does it start above? Put down, pay attention. Listen, you guys, seriously, you're gonna have to start putting the phones away. Like, I'm gonna just start asking them on the desk, because you can't keep doing this. You can't study physics for 30 seconds, then come back to what you're doing. You can't. You have to be in the moment. Start paying attention.
Oh, I forgot to tell you.
Seriously. Your graph should look like this. Okay? It should be above the axis the whole time. Make sure that you put in the correct answer. Do not erase your guess. Let's go to the third one. Moves left, pauses, continues left, just like a very brief stop, right? Then stops, then quickly right. Does anyone else want to come up and try? It's a lot of fun.
Me.
What is our big surprise?
Me. Sleep.
No, I'm doing that.
Okay, so here's what it says. Moves left. Which way's left? Okay, left. Pause. Continues left. Stops. Then quickly right. Can you come this way a little bit? Because it's got to be a little closer to that
I honestly
sensor.
don't even know what to guess.
You should have guessed already.
That's how I'm going to start.
I will.
Please guess.
Go.
Oh, too fast.
Pause.
That was like
That's not a pause, that's a stop.
That was a pause.
And now quickly.
Oh, hang on. Okay. No, that bunch like that.
Okay, what did he do?
Did I do it?
When he turned, right? Yeah, you can't get your body in the way here, right? You want to come on this side and do it? Okay, you come on this side. Everything will be backwards, but...
Just tell him to the right. Okay, move to the right.
Okay, so it's
Right
right,
and
pause,
Like stop.
No, just
three,
left.
full stop.
Okay.
Here, and then... Yeah, make that sound too, it helps. Actually, that one wasn't too bad. Okay, are you ready? Practice one more time. Show me.
Right.
Yeah, pause.
Right.
Right.
Pause.
You forgot to say room. Ready? Here we go.
The second one's a stop.
Pause. And stop. And now. Perfect.
Oh!
Is that what you guessed?
You did good, man. You did good.
How can we tell? How was his speed here compared to his speed there? Was it pretty close to the same?
No.
Pretty close. Would you say he was much faster here?
Yes.
Yes, much steeper. Well done. Okay, now, you've got 3 graphs there. I need the words to make them. The description. Write the description to make those graphs. And we only have 6 minutes, so it's going to be a real tight time here. I'd like to get this done if we could. So you got about 90 seconds to do all 3, Nate. Start now. Go.
I'm 9 kilometers away from home. I have to walk there. It takes me 10 hours.
Let's go real quick here. How do we make the first one, Nate? Come on down. Make it. Show me the graph. How do we do it? Where do you have to start? It's above 0, so you have to start where? Josh, what's going on? You got to start here, right? Which way is he going to begin with? Don't back up. Don't back up. He's got to go what? Left.
Stop.
Pause.
Stop.
Well, yeah, left, pause, left, right? This should be pretty easy.
Wait,
Wait,
so,
you're right, pause, right.
okay, ready?
Yeah, go.
You didn't go enough to win.
What the heck is that? Go. There we go. Is that close enough? It's just the scale that's off, right? Yeah. Okay.
So it's like this. It's like,
Yeah, it's just the scale that's off a little bit, right?
okay, I see.
Okay.
I see right there.
Okay, how do we get number 2?
Who do you want to do?
You go.
Right,
Click
stop,
right, pause,
left,
fast, left.
Okay, so he's got to start. Where should he start?
Left.
Start over here.
Zero, right is zero.
Okay, tell him what to do. Right at 0?
Yeah.
No.
No,
Not right at 0. Okay. Okay. Go.
Quickly left. Pause, fast, left.
Wrong way.
What did he do wrong? He's got to go back, right?
Because we're backwards. We're backwards.
When you stand on this side, it's backwards, right?
Oh, for God's sakes,
Okay,
okay.
so quick left, pause, and then fast right.
Go.
Fast right. We're not the sense of right off.
Hey.
Nate is now banned because he's breaking stuff.
I'll do it.
No, you've had your chance. One more round here. Come on. You got 2 minutes. Let's go. Come on, John. Come on down. John. Daddy, come on. Come on. Sam, come on, quick. Oh, come on. Okay, Kia, you're going to have to do it.
Okay.
So it's going to be starting at 0. Don't back up. Don't back up. You can back up to the middle.
It's quick
It's going to be right.
Pause, quick left.
No pause.
Oh, look at that one.
It should be right, fast right, pause, then
Slow left.
slow left.
Okay.
Right? Go. Right, fast right, pause, oh! Okay, try again.
Where's the knee here? Pause.
Okay.
Right, fast right, pause, slowly left. There you
That
go.
was almost as good as mine.
Okay. Good. That's good. Drop your clicker off on the way out, please. Oh, yeah.
Now you can't